In this lecture, we'll discuss quadratic probing. We have seen the formula for linear probing. In quadratic probing formula, we have I square instead of I. So in case of quadratic probing, this is a sequence of locations that will be probed. We add 1 square, then 2 square, then 3 square, and so on. Now suppose a key is mapped to location 8 by the hash function. In linear probing, we tried these locations. But in quadratic probing, we'll try these locations. We are adding 1 square, then 2 square, 3 square, 4 square, and so on. So in linear probing, we probed locations adjacent to the initial hash address. But here, we are probing widely separated locations. And this reduces the formation of clusters. Now we'll take a hash table of size 11 and insert some keys in it using quadratic probing. Again, we'll take this simple hash function. First, we have this key 43. It is mapped to location 10. Location 10 is empty, so we insert it here. Next, we have this key 50. It is mapped to location 6. It is empty, so we insert it here. This key 57 is mapped to location 2, which is empty, so we can insert it here. Next, this key 61 is mapped to location 6. Now, location 6 is not empty. So now, this is the sequence of locations that we have to try. First, we have to try this location 7. This location 7 is empty, so we can insert the key here. Next, we have this key 68 is mapped to location 2. It is not empty. This is the sequence of locations that we have to try. First, we have to try this location 3. It is empty, so we insert it here. Now this key 30 is mapped to location 8. This location 8 is empty, so we can insert it here. Next we have this key 24. It is mapped to location 2. Now location 2 is not empty. So this is the sequence of locations that we'll try. First we'll try this location 3. It is not empty. Then location 6. It is also not empty. Then location 0. It is empty. So we insert the key here. Next we have this key 39. It is mapped to location 6. Location 6 is not empty. This is a sequence of locations that we'll try. First we try this location 7. It is not empty. Location 10. It is not empty. Location 4. This location 4 is empty. So we'll insert the key here at location 4. So this was the explanation of insertion using quadratic probing. In linear probing, we store the colliding keys near the initial collision point, and this results in primary clustering. In quadratic probing, we are storing the colliding keys away from the initial collision point. So this reduces the formation of clusters and thereby prevents primary clustering. But now we have a new problem called secondary clustering. This problem occurs because keys that hash to the same address will always probe the same locations. For example, all keys mapped to location 8 will always follow the same probe sequence. So the keys mapped to same location always follow the same location chain, and this reduces the access time. In primary clustering, clusters were formed by records which are stored next to each other. In secondary clustering, clusters are formed by records that follow the same collision chain. So here we have this cluster. Now this secondary clustering problem is less severe than primary clustering problem, because here two keys will have the same collision chain only if their initial hash address is the same. In primary clustering, different keys can have same collision chain even if the initial hash address is not same. For example, here only keys that are mapped to location 8 will follow this collision chain. Keys that are mapped to location 9, 12 or 17 will follow some other collision chain. So only keys that are mapped to location 8 will be added to this cluster. Now here, keys mapped to these locations 8, 9, 10 or 11 are following the same collision chain. So the chances of this cluster getting bigger are more, since any key mapped to any location inside this cluster will be added to the cluster. And this cluster will increase in size only when a key is mapped to this initial hash address 8. So in secondary clustering, a cluster will increase only if a new key is mapped to the same hash address as that of the other keys of the cluster. Because here clusters are formed by keys that have same initial hash address. In primary clustering, the cluster size would increase if the initial hash address of a new key lies anywhere inside the cluster. So this cluster will grow if any key is mapped to location 8, 9, 10, 11 or 12, and this cluster will grow only if a key is mapped to location 8. Apart from this secondary clustering problem, another problem with this quadratic probing is that it can't access all the locations of the hash table. An insertion operation can fail in spite of empty locations in the table. In linear probing, an insert operation will fail only when the table is full. To reduce this problem, we can take the size of hash table to be a prime number. In that case, at least half of the locations of the hash table will be accessed. Now, both primary and secondary clustering problems can be reduced by using double hashing, which we'll discuss in the next lecture.